Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable equations. So let's get going. Problem. Solve x square d square plus xd plus 4 into y equals to 2x ln of x. Ln in the sense natural logarithms, right? Or 2x log x to the base for x greater than 0 for all positive x. Solution. Given differential equation, x square d square plus xd plus 4 into y equal to 2x into log x to the base e. Okay, so here we are having variable quotients, so we'll reduce this to constant quotients by making some substitution. Okay, and also we are given a Cauchy's equation. Now let's make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd equals to theta and x square d square equals to theta of theta minus 1. Right? Now this equation becomes theta of theta minus 1 plus theta plus 4 into y equal to 2 into replace x by e power z and log x to the base e by z. Right? Now this equation becomes theta square minus theta plus theta plus 4 into y equal to 2z e power z. Here minus theta plus theta gets cancelled and we'll get theta square plus 4 into y equal to 2z e power z. See, we got constant quotients, right? And also this is in f of theta into y equals to some function of z operator form, right? Which is in operator form. F of theta into y equals to q of z, where f of theta equal to theta square plus 4. Now we need to find general solution to the given equation, which is given by y equals to yc plus yp. Here we'll find yc firstly using the auxiliary equation and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta square plus 4, right? Let's replace this differential operator by m, so that we'll get f of m equals to m square plus 4. Then our auxiliary equation becomes m square plus 4 equals to 0. We need to find roots. Let's take this 4 to RHS, we'll get m square equals to minus 4. Then m equal to plus or minus square root of minus 4. Then m equals to plus or minus, we can write square root of minus 4 as square root of minus 1 into 4. This equals to plus or minus square root of minus 1 into square root of 4. We know that square root of minus 1 is I and square root of 4 is 2. We'll get plus or minus 2y. Right? Complex conjugate roots. Therefore, the roots are complex or complex conjugate. So we got complex conjugate roots, right? We know that a plus ib is a complex number and its conjugate is a minus ib. Likewise, a minus ib is a complex number and its conjugate is a plus ib. So we'll call a plus or minus ib as complex conjugate roots. If we have m equals to a plus or minus ib, then yc will be e power a into z into c1 cos bz plus C2 sine BZ, right? In case of A0, we'll get e power 0 into z, which is e power 0 into C1 cos BZ plus C2 sine BZ. Since e power 0 is 1, so we'll get 1 into C1 cos BZ plus C2 sine BZ, right? Which is C1 cos BZ plus C2 sine BZ. Now, compare plus or minus 2i plus with plus or minus ib. Then for b equal to 2, let's write our complementary function. Yc equals to C1 cos BZ plus C2 sine BZ. This becomes C1 cos 2Z plus C2 sine 2Z. See, now we are having Yc in terms of Z. We need to write in terms of X. So we'll replace Z by log X. Then we'll get Yc equals to C1 cos of 2 log X plus C2 sine of 2 log X. So this is our required Yc. Let's now find Yp, particular integral. We'll find Yp using 1 by f of theta into q of z. We have f of theta, theta square plus 4, and q of z is 2z e power z. We can write it as 2 into 1 by theta square plus 4 into e power z into z. And this of 1 by f of theta into e power az into v form, right? Now we'll shift e power az towards left by replacing theta with theta plus a, and later we'll operate v with 1 by f of theta plus a. Now compare e power z with e power az. Then for a equals to z, we'll find, for a equals to 1, we'll find theta plus a, which is equals to theta plus 1. Now shift e power z towards left by replacing this theta with theta plus 1. We'll get 2 into e power z into 1 by theta plus 1 whole square plus 4 into z. Now Yp becomes 2 into e power z into 1 by, expand theta plus 1 whole square using a plus b whole square formula, we'll get theta square plus 1 square 1 plus 2 theta plus 4 into z. Then Yp becomes 2 e power z into 1 by theta square plus 2 theta plus 1 plus 4, 5 into z. See, this is of 1 by some function of theta into z power k form, right? Now, we have to take the lowest degree term common from all the 3 terms. But the first 2 terms does not has 5. So, we have to multiply and divide 5 to the first 2 terms, so that it will be easy to take 5 common from these terms. Okay, this equals to 2 e power z into 1 by, now take 5 common from these 2 terms, we'll get 5 times theta square plus 2 theta by 5 plus 1. Okay, into z. This becomes 2 e power z into 1 by 5 into, we can write this as 1 plus theta square plus 2 theta by 5 into z. Now let's split this fraction as 2 e power z into 1 by 5 into 1 by 1 plus theta square plus 2 theta by 5 into z. See, the second fraction is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse. This equals to 2 e power z by 1 by 5. Sorry, 2 by 5 or 2 e power z by 5 into 1 plus theta square plus 2 theta by 5 whole inverse into z. So now we are going to apply binomial series expansion formula in order to expand 1 plus theta square plus 2 theta by 5 whole inverse. So we are going to use 1 plus x whole inverse formula, which is equals to 1 minus x plus x square minus x cube plus so on. So before applying this formula, we'll find derivatives of z. Theta of z is 1. Theta square of z is, we can write theta square of z as theta of z. We have the value of theta of z, which is 1. Now find theta of 1. Derivative of 1 with respect to z is 0. So theta square of z is 0. Likewise, theta cube of z is 0. And so on. In general, theta power k of z is 0 for k equal to 2, 3 and so on. Right? Now keeping this in mind, we'll expand 1 plus x whole inverse using this formula. 1 plus theta square plus 2 theta by 5 whole inverse equals to 1 minus of theta square plus 2 theta by 5 plus theta square plus 2 theta by 5 whole square minus theta square plus 2 theta by 5 whole cube plus so on. Okay. This is equals to 1 minus 1 by 5 into theta square plus 2 theta plus 1 by, see, we can write this as theta square plus 2 theta whole square by 5 square, right? We'll get 1 by 5 square into theta square. Let's expand theta square plus 2 theta whole square, which is equals to theta square whole square plus 2 theta whole square plus 2 into theta square into 2 theta, which is equals to theta power 4. Since a power m whole power n equals to a power m into n, then theta square whole square will be theta power 4 plus 2 square 4 theta square plus 2 2s are 4 theta square into theta power 1 is theta cube, right? We'll get theta power 4 plus 4 theta square plus 4 theta cube, right? Plus, sorry, minus theta square minus 2 theta whole cube by 5 cube. Okay, we'll get minus plus and so on all the terms. So if you notice, we are having all the terms from here are higher derivatives, right? Involves higher derivatives otherwise. So we can neglect completely all the terms from here because the higher derivatives, theta square, theta cube, so on are zeros, right? So the terms from here can be omitted completely and also theta square from the second term. Now coming to yp, this is equals to 2 e power z by 5 into 1 minus theta square plus 2 theta by 5 plus theta square plus 2 theta by 5 whole square minus theta square plus 2 theta by 5 whole cube plus so on into z, right? This equals to 2 e power z by 5 into 1 minus 1 by 5 into theta square plus 2 theta plus 1 by 5 square into theta square plus 2 theta whole square minus 1 by 5 cube into theta square plus 2 theta whole cube plus so on into z. Okay, we got to know that all the terms from here involves higher derivatives, right? Or if you want, you can write expansion of theta square plus 2 theta whole square here. And expand theta square plus 2 theta whole cube also if necessary. See, I try to expand theta square plus 2 theta whole cube. I'll just write it directly. If you want, you can check it. Just put it on paper. You'll get to know the expansion. Plus so on into z. See, here you are having theta power 4, theta square, theta cube, theta power 6, theta power cube, theta power 5, theta power 4. So all are higher derivatives, and here also we are having a higher derivative theta square. So we can neglect all the higher derivatives and completely the higher derivative terms from here. Since theta power k of z equals to 0, for k equal to 2, 3 and so on, so neglect higher derivatives theta square, theta cube and so on. Then this becomes 2 e power z by 5 into 1 minus 1 by 5 into 2 theta into z, right? This is equals to 2 e power z by 5 into 1 minus 1 by 5, 1 by 5 into 2 theta is 2 by 5 into theta of z. Then yp becomes 2 e power z by 5 into 1 minus 2 by 5. Okay, 1 into z is z minus 2 by 5 into theta of z. This is equals to 2 e power z by 5 into z minus 2 by 5 into theta of z value is 1. Which is equals to 2 e power z by 5 into z minus 2 by 5. See, we are having yp in terms of z. We need to write in terms of x. For that purpose, we'll replace e power z by x and z by log x. Then yp becomes 2 by 5 into replace e power z by x into z. Replace z by log x minus 2 by 5. Okay. So this is our required yp. This is our required yp. We got yp and yc. Let's write the general solution now. The general solution is given by y equal to yc plus yp. Then y equal to yc, c1 cos of 2 log x plus c2 sin of 2 log x, and yp is plus 2 by 5 into x into log x minus 2 by 5. This completes the problem. So we have seen a problem from higher order linear differential equation with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.